friends, how are you all? It's IGCSE.science.notesz. I'm there on Instagram and YouTube, and let's start.
The revision of Chapter 2, which is types of bonding. Covalent bond, ionic bond, a metallic bond, So we first need to understand this definition, which is an ion. An ion is a charged particle by gaining or losing electrons. When protons is more than electrons, we form a positive ion. And when electrons is more than protons, it forms a negative ion. But how can you remember this? Okay, imagine that electron is a bad particle. And so, when an atom loses one, it gets happier, like it becomes happy. It gets positive energy. So, it forms a positive ion. But when it gains one bad particle, which is the electrons, it becomes sad. It turns to be a negative particle. It's now a negative ion. So, yes, mostly, or actually all the time, metals lose electrons and non-metals gain electrons. So metals such as group 1, 2, transition metals and whatever lose electrons because as we said before, they form a positive ion. So for example, they are 2, 8, 1, and the non-metal is 2, 8, 7. So they lose one electron to give it to this one. So when they lose this, they become 2, 8 noble gas, which are unreactive, and this is plus 1. So it becomes 2, 8, and 8 as it gained 1. So when you lose a bad electron, you form a positive ion, and when you gain a bad particle, which is the electron, you form a negative ion. And as much as you lose, as much as you form an ion, okay? Now we have the ionic bond. Let's start with it. Ionic bond is the transfer of electrons from a metal atom by losing to another non-metal atom by gaining, forming positive and negative ions. The two ions have opposite charges, so they attract each other. The force of attraction between them is called the ionic bond, which is very strong. So we can know over here that the ions attract each other as they have opposite charges, and the forces of attraction between them is called the ionic bond. The ionic bond is the force of attraction, and it's actually very strong. You have to know now the properties. They have high melting and boiling point as they have strong ionic bonds between them. They are usually solid, and compounds are usually soluble in water. Ionic compounds can conduct electricity when molten or dissolved in water. So 1, high melting and boiling point. 2, usually solid. 3, compounds are usually soluble in water. 4, ionic compounds conduct electricity when molten or dissolved in water. As they're already soluble, so it's easy to do. Now let's know how to draw an ionic bond. So you basically, for example, for sodium chloride, you write sodium, then chloride, you put the brackets, you put the ion of it, the valency, Na is in group 1, so positive 1, Cl is in group 7, so negative 1, because 7 minus 8 equals negative 1. Okay. Check group the first video, which is for chapter 1, to understand this part in a better way. And then now you put the circle of it and the circle of it. You make sure you draw here all the atoms, 1, 2, 3, 4, 5, 6, and 7, and the one you gained. And over here, just switch the valencies and write it over here. So at the very end, it's NaCl. Now, do magnesium oxide by yourself and check it from over here. Oh, actually, by the way, I did not mention this, but I'm mentioning it right now. When 1 and 1 are the same thing, you just don't write them. So over here, when 2 and 2, they are the same thing, they cross each other. So at the very end, you just write MgO this way. Here is the lattice. It's a giant ionic structure. Its meaning is that it has a regular arrangement of alternating oppositely charged positive ions and negative ions. Again, definition. giant ionic structure, lattice, regular arrangement of alternating oppositely charged positive ions and negative ions. This is the drawing of the lattice. And this definition is very important. Radicals are very important. You have to know here that positive one is only ammonium, negative one is hydroxide, nitrite, nitrate, hydrogen carbonate ion. Negative 2 is carbonate, sulfite, and sulfate. Negative 3 is phosphate and phosphite. Here's an example for you. You have to know that 8 is always greater than 1, with 1 than 8. So 8 here is 4, 8 is 3. 8 is negative 3, 8 is negative 2. Carbonate ion. So let me tell you something. Carbonate ion is always CO3. So carbonate is CO3, ion is CO3 negative 2, hydrogen carbonate is hydrogen, then CO3 as well. We have here practicing area, but now let's know this important points. Hydrogen metals form positive ions. Non-metals form negative and their name ends with "ide". Chloride, for example, bromide, iodide. Yes, group 8 atoms are unreactive because they have full outer shell of electrons. They are noble gases. Noble, gentle, never react. Basically, again, another point. These are negative ones, okay? This is positive one. C and S, both of them, they are only 2, so they form negative 2. P. Okay, whatever. This is a letter P. So 3. Okay, only phosphate and phosphate. Let's talk now about covalent bonds. Covalent bonds is share of electrons between nonmetals. Only nonmetals. You can never find covalent bonds between metals. Only nonmetals. And molecule is a group of atoms held together by covalent bonds. So simple covalent bond. Here's a single covalent bond where you only share 1 pair of electrons. Here's a double where you share 2 pairs, which is 4 electrons. Triple where you share 3 pairs, which is 6 electrons. Here are some examples, and here are other examples. Here, HN, HN. This is a single with 3, and this is how you write it, N and 3 H's and H3, and this is how you draw it. Here, there is double bond, so this is how you draw it. And if I drew the other one like this, so you're gonna write it the way you draw it. We have some properties which are opposite of or with ionic. They have low melting and boiling point. They do not conduct electricity. They are gases and liquids, but few are solids. They are soluble. Their solubility in water is less than ionic compounds. These are the physical properties of ionic bonds. These are the covalent ones. You have to know them very well. You're gonna find all these notes in the Instagram account. So basically the electrostatic forces are for ionic bonds, but the intermolecular forces are for covalent bonds. Now let's talk about the giant covalent structure. We have a definition, which is macromolecules. Macromolecules is made of billions of atoms bonded together in a covalent structure. And we have also something called allotropes. Allotropes is a different form of the same element. There's also the word graphite, which is layers of hexagon bonds by weak van der Waals forces, so layers slide over each other. They have 3 properties, or actually there are 2. They are soft and slippery, as layers can slide over each other. They are also good conductors of electricity, as it has free many electrons carrying the charge. They also have low density and high melting point. They have a couple of uses: electrodes, as they conduct electricity; pencils, as they are slippery and can slide; lubricant, as they are soft. Now let's talk about the properties of diamonds. Diamonds are actually tetrahedral in a tetrahedral arrangement. They are very hard, as each atom is held by 4 strong bonds. They are very high in their melting points, as they need very big amount of energy to break its bonds. They have high density and they can't conduct electricity. They have no free electrons, but they can conduct heat. So basically over here again, the uses are for graphite. These are the uses of graphite. They are soft and slippery. They have low density. They have high melting point. They are good conductors of electricity. Here, they are very hard. Have very high melting point. They have high density. They can't conduct electricity, but they can conduct heat. Because of this, they are used in jewelry as they are shiny, and they are used in cutting and drilling as they are very hard and strong and sharp. Now, this is silicon oxide. They have very high melting point because they have very strong bonds. So they need very strong bond. They need very high heat to break them. They're very hard as they have strong bonds. They does not conduct electricity because no free electrons. They are insoluble in water and organic solvent. Now let's talk about the metallic lattice. I have a definition. That lattice is a regularly arranged layers of positive ions embedded in a sea of delocalized electrons. Metallic bond is the force of attraction between layers of the metals, positive ions, and sea of electrons they are embedded in. Here, as you can see, the big ones are positive and the small ones are negative. We have also some properties of metals. They are malleable, they are ductile, as layers of positive ions can slide without metallic bond breaking because electrons are free to move. They are also good conductors of heat and electricity. Their metallic bond is strong in transition metals but weaker in group 1. That's why their metallic properties are not the same. Here is an important definition. Compound is a single substance formed by a chemical reaction. Mixture is a two or more substances and no chemical change takes place. When made, element is simplest form of a pure substance consisting of only one type of atoms. They cannot be broken down physically or chemically. Let's solve some questions. Solve this question together. The structure of methanol is shown. Which diagram shows the arrangement of outer shell electrons in a molecule of methanol? You have to know that this is only one pair. So 2 electrons. Which is 2 electrons? Right, and right. But hydrogen only have 1 proton, which is here in the covalent bond. Then where did this come from? This is wrong. So it's not B. And okay. Now let's see this one. Right, and right. Now let's see the double bonds. This is right, and this is right, and this is wrong. So this is wrong. Now, does it have electrons left for the oxygen to share? Yes, it does have, because there are 6. So 2, 4, and this is the 6. So this is completely wrong. So it's C. Now let's solve this question. Chromium forms the compound chromium 3 sulfate. What does 3 present? It presents the oxidation state of chromium. So does it show the charge on a sulfate ion? No. Does it show also the sulfate ion's charge is not 3. Okay, it's positive, it's negative 2. The charge, as we said, the radicals. Okay, the number of chromium ions combined with 1 sulfate ion? No. The number of sulfate ions combined with 1 chromium ion? No. And the oxidation state of chromium? Yes. 3 belongs to chromium. It doesn't belong to sulfate. Let's solve this question too. Ethanol is a liquid at room temperature and boils at 78 Celsius. Sodium chloride is a solid at room temperature. Which statement about the bonding in ethanol and sodium chloride is not correct? So basically, sodium chloride is solid at room temperature because it's an ionic bond, metal and non-metal. So which is not correct? Not correct. The ethanol molecules are held together by weak attractive forces. I thought it was incorrect, but it is correct. Okay, because it's weak attractive forces. Weak attractive forces. The point was at weak covalent and weak attractive forces. It's weak attractive forces is right, however weak covalent bonds is wrong. Now, the molecules N2, C2H4, CO2, and C2 shit all covalent bonds. All have covalent bonds. These bonds consist of shared pairs of electrons, which gives the total number of shared pairs of electrons in the molecules shown. It's C2H4 because its total number of shared pairs of electrons is 6. We have the last question. Metals are malleable. Which statement explains why metals are malleable? The layers of positive metal ions can slide over each other's. Okay? I wish this video was useful for you. Bye bye.